Learning curve. Earlier, which chapter? I mentioned this one briefly, the experience curve. So from previous experience and then learning from previous work, we can make it faster if we repeat the same job again and again. Maybe faster, maybe cheaper. So that is learning curve. So learning curve looks like this. First time, if it takes 100 time unit, then next second one, third one, unit time decrease like this. So learning curve is a line displaying the relationship between unit production time here and the cumulative number of units. So 1, 2, 3, 4, and so on. So it looks like this: 100, 90, and so on. So some underlying principles of learning curves. Each time of performing a task, it takes less time than the last time. So first time, 100, 90, 84, 62, and so on. And then the unit time will decrease at a decreasing rate. Decreasing rate. So if first time production time is 100, and the second, so 100 minus 90 is 10. Then from 90 to 84, 62 is 5.38. Then 84 to 62 is 3.62. Then 81 to 78.3 is 2.7. If my calculation is right. Then from here to 4, 1.2. So the unit time, production time, or service time, whatever time, decrease at a decreasing rate. So decreasing rate also decrease. So this one is like we call that reverse exponential curve, and then the reduction in time will follow a predictable pattern. So here, if we know time for unit 6, then we don't know 7s, but we can expect, because the decreasing rate has certain pattern, so we can expect like this: -2, then 74 something like this. And then a learning curve can be used to estimate production time, service time, certain time. And also we can use this one to estimate cost, production cost, service cost, material cost, and so on. That is learning curve concept. Then in the real world, they use this learning curve. So learning curve effect, very old one, for the Model T price, and then the unit produced to price per 1 unit, 86% learning curve. This learning curve, learning percentage, I will talk about this learning percentage in a moment later. And then aircraft unit produce time, 80% learning percentage. And then GE equipment maintenance, number of replacement is like time, so 76%, and so on. And also in the industry, why this learning curve is important. Here, x-axis accumulated volume, so increasing like the industry size or volume size and production size increase like this. Then price per unit, first time high here, then typical learning curve decrease like this. So production cost decrease like this if increase the volume. And then also industry, the price also decrease like this. So if the company's learning curve or percentage is under the selling price, then there is no profit or margin. But over higher than that industrial average learning percentage, then there is kind of loss. So compared to industry average learning percentage and then a company's learning percentage, this company's learning percentage should be higher than industrial learning percentage. Okay, here learning percent. There are two types of learning curve. First one is arithmetic learning curve. This one is simple exponential curve. So if learning percentage is 90, looks like this, and then 80, more, deeper, and then 70, deeper, and so on. So with the number, if learning percentage is 90%, then the first one, if it is a 100 time unit or a cost or whatever, then second one, 90, because times 0.9 learning percentage. If learning percentage is 80, then times 0.8, 80, times 0.7, and so on. So if learning percentage is lower, then this like the first one, second one, difference is bigger than lower learning percentage, deeper, or the distance is now longer. Then we call that doubling approach or doubling method. This arithmetic learning curve concept follow this doubling. When unit number doubled, then just times learning percentage. So learning curve, if we use arithmetic learning curve concept, then when it's doubled, this, then times B. B is learning percentage, 0.9. And then from 2 to 4, double, then times 0.9. That is learning percentage. And then again, from 4 to 8, times 0.9, doubled, and times B, that is 0.9. The same, 0.8, 0.8, 0.8, 0.7, 0.7, 0.7. So this is an arithmetic learning curve concept, doubling approach. And the next one is logarithmic learning curve. If we use an arithmetic learning curve concept, then this one relatively curve, but this one logarithmic learning curve relatively straight. If we use an arithmetic learning curve concept, then even we know second one, we cannot get the third one. If we know 1.5, then we can get a third one when it's doubled. If we know third one, then we can get sixes. But if we know only one and then learning percentage, then 2, 4, 8, and so on. But if we use this logarithmic learning curve, then we can get any unit numbers, price, cost, and time using this formula. So y-axis first unit k, that one is first one, and second one is y2, third one is y3, and so on. So yx, that is unit number. K is initial or first time or cost for first one. So K. Then X is unit number, and then N. N is this one. So N is log 2 divided by log 2. So always this one is 2. So we can use this logarithmic learning curve concept. Then we can get any unit cost or unit time for any unit number. So this one relatively straight. And then another approach to get unit price, unit cost, unit time, that is using learning curve table. The unit improvement factor for unit 8 at 80 learning percentage. That case, we can use the table, learning curve table that is attached in your lecture notes. So it's like unit improvement factor, only one unit to produce only one unit and then unit number. So from this one, unit number 8 and then learning percentage is 80%. Then unit number 8, then learning percentage 80. So unit factor, improvement factor is 0.520. I will tell we use this unit improvement factor later. So anyway, unit improvement factor is this one. Unit improvement factor, go back to this logarithmic learning curve formula, looks like this. Then if we want to get y eighth, then using the logarithmic learning curve formula, then k is not given yet, times X is 8, and then N is low, B is the learning percentage, so 0.8 divided by log 2. This is the learning percentage. So that is equals K times, here I call a unit factor. So unit improvement factor, this one I call unit factor, ACE at 80%. So this unit factor is the same as this part of logarithmic learning curve part. This one is the same. So if we use this chart table and then find that one 0.520, so that is 0.512, and then this one also 0.512, the same. Okay, then next one. And what is cumulative improvement from unit 1 to 10 at 90 learning percentage? Unit factor, unit improvement factor, and the cumulative improvement factor. Learning curve looks like this. Then first one, second one, third one, and so on. So first one is K, Y second, Y third, and so on. Unit, when we find YX, 1 unit, cost or time, then we use unit improvement factor. That is like only one. But if this one asks, like 1 to 10, so all area cumulative, so that will be y k plus y1, y2 plus y3 up to y10. So to get this, if we use unit improvement factor, then equals k plus k times unit factor 1 plus unit factor, no, we don't need 1 because 2, 3, 4, k is 1, so 2. So unit factor 2, unit factor 3, unit factor 4 up to unit factor 10, like this. Then this one is unit factor 2, 3, actually from 1, that will be cumulative factor 10. So what is cumulative factor, improvement factor from 1 to 10, 90%? That is from the second table, cumulative improvement factor 90% and 10, then that is 7.94. So that is unit factor 1 to from 1 to 10. Add or that is 7.994. So cumulative improvement factor from 1 to 10. Actually, we don't need the 1 because this cumulative factor always from 1 to that unit number. Cumulative factor 10, that means from 1 to 10. Cumulative factor 50 is from 1 to 50. Okay, example. Unit number 1, 2, 3, 4, 5, 6, 7, 8. Then K is not given, but we have a second one cost, the third one cost, the fourth one cost, and so on. Okay. Because this one doesn't give us initial cost, the cost of, to produce first one, and then it doesn't give us learning percentage. But as long as we have second one, first one, then we can get first one, and then we can get first we can get learning percentage first, and then we can get K. So from arithmetic learning curve concept, the relationship when it's doubled times B, when it's doubled times B. So relationship y fourth equals y second, y fourth, first, second times B. We need B, so we can transform this one, y fourth divided by y second each side, then it will be B. So B equals, we have number here, so 86.7 divided by 102. That will be so that will be like this. So 0.85, 0.85. So learning percentage is now 85%. And then again, from here, 1 to 2, then times B. So y second equals K times B. We know B here, and the y second here. So anyway, K equals y second divided by B. So y second is 102 divided by 0.85. So that is a calculation there. So initial cost, or cost to produce the first one, 120. this calculation. Okay, next. Estimate the cost to produce the 20th unit. The 20th unit, that will be the Y20th at 85% equals K times, if we use unifactor table, then find the unifactor at 20. That is from the table 85 and 20, so 0.4954. So K is 120, and then unifactor 20 is 0.4954. So unit cost to produce 20th unit is 59.448. This one is an easy one. And next one, estimate the cost to produce the 32nd unit. So 32nd unit, 32nd unit, that will be Y 32nd equals K times unifactor 32nd. So try to find unifactor, unit number 32 from the table. We can find 32. So this case, try divide by 2, because from 16 to 32, when it's doubled, then times B. So if we cannot find 32, then divide by 2 is 16. If we can find the 16th, then times B. So this is 32nd unifactor. So from the chart, 16th unit at 85%, that is 0.5220. So that will be 0.522, 0.85 equals 53.24. So this one is cost to produce 32nd unit. Then if we use logarithmic learning formula, then we may write like this, equals K times X log B divided by log 2. That will be 120 times X is 32, and log B is 0.85, divided by log 2. So that is supposed to be this one. So I will try to calculate. First, I need log now 0.85. Log 0.85 divided by log 2 equals. So this part is negative 0.23446 and so on. So 120 times 32 negative 0.23446 and so on. That will be power 32. Okay. Actually, 120 times 0.4437. That will be times 120 equals 53.244. So close enough. So that will be, this one will be the same as this. Okay. That is so far finding a unit cost. And the next one is cumulative. Estimate the cost to produce 40 units from 11th to 50 units. 50th unit. 40 units from 11 to 50. This one, if I draw graph visual, then it looks like 11 to 50. So 50, 11. So this area. Because the chart, you need the cumulative factor, cumulative improvement factor chart gives us from 1 to that designation number. So this one equals up to 50 minus because we need from 11, so we should subtract up to 10. So subtract up to 10. So that will be y 11 to 50. So that will be k times cumulative factor 50 minus cumulative factor 10. So looks like this. Same. Cumulative factor 50 minus cumulative factor 10. Then from the chart, the second table, 85%. Cumulative factor 50 is 25.51. And cumulative factor 10 is 7.116. So 25.51 minus 7.116. And the cost to produce 40 units from 11 to 50. That is $2,207.28. Okay. This is learning curve. And I think that's all. Okay. We're done. Because this one is the last class, I will not give you any assignment. So it's early, but that's all. And last class, I announced your final project. So whenever before end of November. So during that time, if you need my help, question, then when you make your team meeting, then so Tracy just be a leader, so lead your team
Yep.
and then teamwork. So during that time, if you need me, and then when you have a meeting, then invite me.
Okay.
First asking me the time, available time. You know, you have a class on Tuesday and Thursday.
Yes.
So maybe after your class, or I have a class on Friday. So maybe not available. Or even the weekend, it's okay. Usually nighttime, I will be available.
Okay.
You know, sometimes when my colleague, Professor Ed, I'm not sure that if it is the right pronunciation, Kean University, Kean University in New Jersey. He worked there, and then we work together to do research. So sometimes he asked me a meeting. Then we usually meet after midnight. So sometimes we even we work and then chat until 4 a.m.
Wow.
So at night it's okay. When I was doctoral student, one of my colleagues said, if you call me after 12, it's okay. If you call me before 12, AM or PM anyway, AM 12 or PM 12, after 12 is okay, but before 12, it will bother me. So, like, you know, go to bed like early in the morning, like 4 or 5. So we sleep until 12 noon. And then midnight, we are okay. So we said, after 12 is okay, but before 12, don't call me. So anytime at night, I will be available.
Okay. Thank you.
Okay. So thank you very much for your like participating and being patient.
Well, thank
Okay.
you. It was a great class. I love how you
Yeah, I
break
hope.
down
Yeah. I tried
everything.
the best and I can do. Okay, so
Very
anyway,
helpful. Thank
thank you
you.
very
Yeah, it was a
much.
great
See
class.
you.
I enjoyed it too.
Okay.
Thank you so much.
Me
It was a
too.
great
I
class.
enjoyed
Thank
with
you.
you.
Bye.
Okay.
All right. Well, thank
Bye.
you. Good night.
Good night.
Good night.